Okay, sounds good. So hopefully, you guys remember that yesterday we worked on the lemonade problem or lemonade program, and it was supervised learning and it was regression, as we found out. Today we're actually going to be doing something similar, except it's going to be a little more complicated. So yesterday our regression equation was y equals 2x, right? But today what we're going to be dealing with is an equation that looks more like this. And it looks really complex, but it's actually not that hard to understand. So we're going to be talking about Boston housing prices. And it's similar to the lemonade problem that there's like an equation, but as you can see, there are multiple inputs now. It's not just in the lemonade the temperature and the sales, but for Boston housing, there's going to be multiple inputs. So this first one is the crime rate, and the second one is going to be, I think this is I'm not sure, but like 7 is the age, so like the age of the property. So all of these are factors, and you can see number 10 is the tax. So there are all these different factors there are in determining the actual price of the house, right? So we're gonna be using AI to like put in all this data about all these houses and the different parts of the house, the different attributes or factors that determine how much the house is. And as we go on, the reason why we're using all these different factors and we're finding out the 14th column is what the AI is predicting, or it's going to be the output of whatever our AI does. And this MEDV stands for the median value. And the reason why we're dealing with a median value, as you can see here, is that there's a big variety of different prices in housing. And because there's so many like very expensive houses or very cheap houses, it gets messed up if we use the average or the mean value. So in this case, we're forced to use the median value because it's just a better way of determining like the price of a house using the median value. And this is basically what we're going to be using and doing. Um, this is a model we're talking about. Of course, it's called the Boston housing prices, and the output is 14th column right here. It's the median value, and it's just the numbers. And all these the other columns, 1 through 13, remember, these are all just factors relating to or that might affect the housing price. So like the crime rate at number 1, that might determine like how expensive the house is or the age of like how old the house is, stuff like that. All of these are possible factors that we're considering. And then unlike the lemonade problem where it was just y equals 2x, you can see that this one is the output is going to be, you can think about y being the median, so MEDV right here. And then there's a bunch of, instead of just one x, in this case, there are 13 different x values, and they all contribute to this 14th, the output. So all these 13 different factors are each contributing to how much each house is in Boston. And so, yeah, basically this is a model that predicts like the median value, and all 13 of these factors are considered, and they're calculated in this big equation. And don't worry about this. It's like the AI is doing this for us. It's going to create the equation for us. And the process for what we're doing is going to be exactly the same as the lemonade one, or it might be a little bit different, but the overall is going to be exactly the same. So the first thing we're going to do is prepare the data, and that includes, splitting the independent and dependent variables. And then number two, if you guys remember, we're going to create the AI model. And then number three, we're going to actually train the model. And then finally, at the end, we're going to predict using the model. So we're going to use the model at the end. And you can imagine, instead of just one cause for this Boston housing thing, we're going to have 13 different causes or 13 different factors that are going to lead to the median value at the right instead of cups. So the cause and effect, everything about it is the same except for the actual details of what we're doing. And before we start coding, we're just going to take a look at like what the code might look like. If you guys remember yesterday, when we're preparing the data, we need to read the file with all of our data. So let me open this up for you guys. So this is what the data file is going to look like. It looks really like complex and whatnot, but luckily we're going to organize it in a way that's easy to understand for us and the computer. And you can see there are these different columns, the median value at the very end, and these 13 different factors. And then the next thing after we've taken all the data and put it as a variable called Boston is we need to split up the independent variables and the dependent variables. So you can see we set independent equal to Boston, and then these 13 columns, all the different factors. So all the inputs we're gonna put in the independent column, or I mean the independent variable, and then all the columns that are the output. In this case, we only have one output, which is a median value. We're gonna set equal to the dependent, because this value, the median value, is dependent on all 13 inputs, and these are all independent values. And then we're going to try printing out the shape, and it should look like this. So there's 506 different, data lines that we have. So this would be one line, this would be another, and this would be like a third line. It's saying that there's 506 of those. And then there's 13 columns in the independent variable, because there are 13 inputs, and then we're going to have one output, which is why we have only one column for the dependent role, which is going to be this median right there. And then our second step is to create a model, right? And I think this is a little cut off, but we want our x values, or we want a variable called x to represent the inputs, which is why we said, Keras layers dot input, and the shape is going to equal 13 because we have 13 different factors that we're considering, 13 different inputs. And then for the y, you can see we have one right here, and this just means that there's one output, and that means that there's one median value that's gonna, be predicted. And then we go on, create the model using models.model. Then we're gonna actually compile the model, and the loss is going to be the exact same as the lemonade. We're gonna see what the difference is between what the value should be and what the model is getting. And then dependent on what we see the loss is, then we can see like, oh, our model is not very good at predicting, so maybe we should change it a little. And then the third step is to actually train the model. And so we just do the same thing we did for the lemonade. And I think this is cut off, so Let me try. Oops. There. All right, there we go. So hopefully now you guys can see it goes a little to the right. So right here, we're finally going to be training the model, and we're going to be using 1,000 epochs. All that means is that we're training it 1,000 times. And then at the very end, we're going to be predicting it using the input values, which is in the independent variable. And then we're going to compare that with our dependent variables. And so, yeah, this is the Boston housing price program. And we're going to get started on that. So we're going to navigate to Google Colab. It's what we used yesterday. I'll send the link in the general chat for you guys. So go over there. And once you're there, I'll give you guys a few minutes to do this, but at the top left, you want to go to File, or maybe you guys see like a login first. Make sure you log in with your Google email first. And then at the top left, you're going to click on File and then New Notebook. And it should open up this Google Colab. And then once you've opened up this new notebook, then let me know in the chat so we can move on. And of course, if you need me to repeat anything or if you're confused, you can always ask. All right, looks like a few of you guys are done already. The first thing we're going to do is I like to name my notebooks. So I'm going to name this one Boston. And I'm going to do teach at the end because I already have a program called Boston. I don't want it to overwrite that. And then, yeah, so I renamed it to Boston Teach. You guys should rename it to something that you guys can remember. Then once you're ready to move on, the first thing we're going to do is we're going to import TensorFlow as TF and import pandas as PD. And then let me add a code block under. So these two are the main modules that we're using for today. TensorFlow is the AR, I think the AI part, and pandas is more like the data managing part. And so our steps are going to look, if you guys go back, you can see that right here. So our first step is to prepare the data. I like commenting out my steps. So I'm going to say prepare data, data. Then I'm going to create another coding block. And then this is going to be, it's going to be creating the model. So create model. Then our third step is to train the model. Train the model. And I'm just going to put fit in parentheses. So I remember that we're fitting the model. And then lastly, we're going to use the model. So number 4 is finally to use the model. And for that one, I'm going to say predict. That's what we're doing. And let me know when we can move on from here. We're basically just setting up, the program. We haven't actually done any coding yet, but are we ready to move on yet? Or does anyone need more time?
We need more time.
All right. All right, if you guys are ready to move on. So the first thing we're doing is we're going to prepare the data. And to do that, we need this huge file of all of our data. And we're going to create a variable called file path and set that equal, oh, sorry if you can't see this very well. We're going to set that equal to this right here. And I'll send the URL of this like huge data set in the general chat so you guys can copy and paste that. Yeah. I sent it in the general chat of the Discord for you guys. So you guys can copy and paste that. And then from there, once we got the file path, we're going to read that, set that equal to a variable called Boston. So we're going to use pandas td.read CSV, and we went over CSV files, I think before. And then we're going to do Boston.head. And if you don't remember what that does, it just prints out the first five, like the first five rows of the data. So you'll see what it does if I run the first two coding blocks. All right. So once I ran those two, you guys can see that it prints out the first five rows of our data set. We can see these 13 columns, and then we have the output median values on the right. And let me know when you guys are ready to move on after this one. I'll give you guys a few more minutes and then we'll move on. think we are ready to move on.
Yes.
So from here, I'm gonna add another code block. This is gonna be like in between. I'm gonna just name this part A because it's in between 1 and 2. But we need to separate the independent from dependent. So we need to separate the inputs from the outputs basically. And so before we do this actually, it'll be helpful to see like the exact columns in this form. So I'm gonna run this. You guys can see it gives us all these columns for us, like the different names of the columns. And from there, we can simply just create a variable called independent and set that equal to Boston. And then you want 2 sets of brackets. And then all I'm gonna do is copy from the first to the second to last terms or whatever printed out. It should look like this. And this is because these are all the inputs, the input columns, while the median is the output. So we're going to save that for dependent. And so when we do dependent equals Boston, and then this one's just going to be med v, the median value. And then to just check if everything's going smoothly and well, we're going to print out independent.shape and dependent.shape. Now when I print this out, it's going to give us 506, the number of rows, and then 13, which are the columns, and then 506 for the rows again, 1 for the column, the 1 output column, and the 13 input columns. So it separated them successfully, it looks like. Once you guys get this to work, let me know and we'll move on to creating our model. You guys still need more time, or are we free to move on?
Franklin,
Sorry, did you say we can move on, or
yes.
yeah? Okay. Oops, that was sick. Okay, so next, now that we've prepared the data, we're going to create the model. And we're going to start with X, which is going to be the inputs. So tf.keras.layers, and then since these are inputs, we're going to say input shape equals 13, because there's 13 inputs, right? Or 13 factors that we're considering. And then y, our output, is going to be equal to tf.keras.layers, and then dense. This one's going to be 1 and then x. 1 just means like how many outputs it's going to have, and we're just going to have 1, that one median value. Then finally, we're going to create the model. Oops, I spelled Keras wrong. Model x and y. Then finally, we're going to compile the model, and we're going to be using loss MSE. And when I run this, it should give you guys this check mark. Let me know when you guys are ready to move on after this. Oh, and by the way, MSE stands for mean squared error. It's just like the difference between what the AI got as an output and what the output should be, is basically what all it is. Um, Looks like we can move on now. So next, what we're gonna do is, now that we've created the actual model, we're going to be training the model. So to do that, we're also going to be, this can also be called like fitting the model. And we're doing model dot fit, and then independent, dependent. Then we're going to have 1000 epochs verbose equals there. And remember, epochs equals 1000. All this means is that we're going to train it 1000 times. And verbose means that verbose is equals 0 means that we're not going to print any of this out. Like we wouldn't want to go through 1,000 test cases. But what we are going to do is we're going to see 10 of them instead, which is why this one has 10 epochs, no verbose. And then I'm going to try running this. This should take a little bit because, it's training it 1,000 times, and that's a lot. But you're going to see only 10 that get printed out. So hopefully you guys can see that the model, it trained itself 1,000 times, and then after 1,000, it just trained it 10 more times, and it printed out the 10. And you can see a lot of different details, how long it took, and then the loss. The most important part is probably the loss, because we see how inaccurate or accurate our model is depending on the loss. And what we want to do is try to minimize the loss as much as possible. So I can try running this again, and you guys can try this out too. So you'll notice as you keep running it, the loss should get shorter or smaller, sorry. Our loss before was, I think, around 27. And you can see our new loss is around 24 or 25. And then we can continue running it. I'll train it one more time. But there might be a few issues with like overfitting, which means that it's trying to, like, I think you guys learned it yesterday. It's trying to account for the different data that it's training on too much, and then it doesn't get like an actual accurate model. And then from here, you guys can see that our numbers are not going down that much. Like we got 24 and 23 before, and they're not going down anymore. And this is because the data that we had, all this data, um, it's probably not a direct, like the lemonade one was you just multiply by 2, right? Whatever temperature it is, we multiply by 2, and that's like the profit. But for this, there's no really easy relation between all these 13 factors and the median value. And the AI is having trouble, finding out this relationship because it like the relationship just does not exist. So maybe our data is not the best, which is okay. But we're gonna finally, after training the model, we're going to use the model. And for this, I'm gonna be printing out predicts independent from 0 through 5. So all this means, all we're doing right here on this line is we're independent 0 through 5 is literally giving us these it's giving us 5 rows of these 13 inputs, and then it's telling the model to predict like what the median value on the right would be using the model. And then right after that, we're going to print dependent 0 through 5, and that's going to give us what it's supposed to be, so the actual value, while the first line is giving us what the model predicts it's going to be. So when I run this, you can see there's some differences, right? Like 20, this is about 30 compared to 24. That's like a 6 number or 6 difference of 6. And then we have like 25, 21.6. So there's a lot of differences, right? So you guys can try this out on your own. let me know when you're finished. But what you should get from this is that our model is incomplete, and maybe our data is also like faulty data. Maybe some of these inputs have no relationship with our output, and so we should delete them. So there's a lot of different possibilities or why like our model is not accurate. But we are going to improve the accuracy of this model later when we learn about deep learning. But that's going to come later. So but get this finished first and let me know when you're done so we can move on.
You can continue.
Okay. So hopefully you guys can see that although it works, like kind of works, I guess. There are a few like there's definitely some error in it because the differences are pretty big. But we're gonna improve it on another day, so be excited for when that happens. We're gonna be talking about. Oops, sorry. So now we're gonna be talking about what was actually happening. Wait, we we can hear you. Can you hear me? Hello? Can anyone else hear me? Like like Roy, Hannah, David, Nathan, can you guys hear me?
We can hear, but we cannot see what you share.
Oh, okay. Let me try resharing my screen. Let me know if this works. Can you guys see this?
It's loading.
Yes. Wait, what did you say? Sorry. Yeah, can you see my screen right now?
No, no.
Can other people see my screen? Oh, okay. It might be like a Wi-Fi issue then. I guess we'll wait for it to load. Yeah, I think if it's still not working, you guys can try closing your Discord and reopening it. Maybe it'll work then. All right, we can see it. Okay, so this is basically what our model is, and this model is known as, or actually before I talk about that, you can see that our shape was 13 because of the 13 different inputs. And you can imagine the equation looks something like this down below. Y equals W1 times X1 plus W2 times X2. And each of these X1, 2, 3, 4, all these different X's are just the different 13 values that were like the input values we were considering. And all of these have different weights. And then like the weight is basically like how important they are. And the AI used or it kept training it to figure out the weight of each of these different inputs. And then at the end, it calculates all these values and then it gives us one output along with a little slight change because like the AI has some bias depending on the data. And so this is like a perfect way of showing this because this equation at the bottom really shows you that it's like 13 different inputs and they each have a different importance that the AI figures out. And so it tries to find the best combination possible in order to give us the most accurate output compared to the actual output. And this model is actually known as a perceptron. And this is because the neurons in our brains actually work in a similar way. Um, like one neuron equals one perceptron. And then yeah, so basically our mind works a similar way as this AI. It takes in a bunch of different inputs, right? And it takes each of them into consideration, whether that's like what you're seeing, what you're smelling, what you're hearing, and it determines something based off of those things, right? And each one of those things has a different weight because like seeing something might be more valuable than listening and stuff like that. And then there might be a slight bias, and that's just it's just like a small shift. And then what we're gonna learn next is imagine if we added one more output or possible output, And then this y2, it's going to be very similar to y1, that the equation is based off of like these different weights. But y2 is going to have different weights than y1. And then this is going to like be the next thing we're learning about. So you guys can see here, we created one perceptron, right? We have 13 different inputs and we're getting one output. The next thing we're going to learn is imagine we have like 12 different outputs, but then 12 inputs, and then we have 2 outputs based off of that. Then it's basically like they're 2 neurons because y1 and y2 are different outputs, right? And the more we have, possibly the more accurate or the more inaccurate it is. Usually, the more you have, it's a little more accurate, but it really depends on the problem. Like for the lemonade one, if we had extra neurons, I think it would be too much because it would be like overfitting for the data because it's like a really simple 2x problem, right? Compared to this, which might be more advanced, so adding more neurons might be more helpful. And that's going to lead into deep learning, which we're going to learn later. But that's basically all I have for today. And I think I can pass it on to Nathan, who's going to talk about something else.
Let me start sharing my screen. One second. So can everyone see like my Visual Studio, or should I move it to like the collab first, or what should I do? Oh, okay. All right. So today we're going to be like making like a scientific calculator. And just like as a preview, like this is supposed to be like what it's supposed to look like. So basically, in this top left corner, you can choose between like a standard calculator, which looks like this, or you can go with a scientific one, which basically is the standard one, but with like more options, as you can see here. So we're going to be programming this today, and and then because you may notice that like this calculator is not using like the console in here. It's like a GUI where it's like you can like physically interact with the buttons and stuff. So in order to do that, we need to import something called Tkinter. So these first couple of lines, basically. So, from this Tkinter module, we want to import everything, and that's represented by the star. The voice is low. Okay. Can you guys hear me? Um, can you guys hear me now? Okay. So anyways, so basically, we have this Tkinter, and we're importing everything. So that's this first line. And then we also want to import mass, and the reason why is because in our scientific calculator we have all of these like pi, cosine, like these trig functions, and then like e to x. So like those technically aren't part of like the default Python, so we need to import the math module in order for the computer to use cosines and sines and whatnot. So that's what that is for. And then finally, this import tinctor.message box. That's mainly for if we scroll down, or actually if I run the code. Basically, you can see like this exit button here, right? So when we do that, then this pop-up comes out saying, "Do you want to exit?" So in order to make that pop-up appear, we need to import the tinctor message box. So yeah, those are just the first 3 lines, and then from there we'll go into this section, which is basically like setting up our calculators, like geometry and stuff. So basically, root is going to be our it's going to be our variable or object storing the tk tkinctor functions and stuff. So here is our root, and we're initializing it here. Then we have our root.title, and we're going to be calling it scientific calculator. That's basically this title over here in the top left corner, if you can see that. Sorry. Okay. So that's the title of the calculator, and then the root.configure background equals this line over here. That's just basically your background color. Here it doesn't really matter because, like, let's say I change it to like red or something, right? As you can see, like the calculator takes up the entire like GUI anyway. So, like you can see this tiny portion of red, but like it's not that noticeable. So honestly, like this line doesn't really matter. So, you can do it pretty much any color you want, because you're not going to be able to see it. Now this resizable thing, basically, this determines whether we can like resize the application. Here we have disabled it because if you resize it, then a lot of the functionality disappears when you like resize it. So it's just better to just turn it off. Um, oh, it's blinking. Okay, I'll just like explain what I said previously then. I think it might be because I'm running the program, so I'll try not to do that. Um, okay, so basically this line is just like saying our background color, which is going to be covered anyway, so it doesn't really matter. But it's still good to have this line because you do want to set like a background. And then this is just making sure that we cannot resize our calculator because otherwise some of the functionality will disappear, and we don't want that. Okay, so this next part, the root.geometry, this is basically like how many pixels by how many pixels we want our calculator to be. In this case, we want it 480 by 568. And then these plus 450 and plus 90 is sort of like our orientation. So like we want it to be like because like if you do plus 0, then it's basically like dead center. So like you're moving it a bit right and then up. Calc equals frame root. That's just basically setting up our calculator class, and we're going to be using it. Basically, it's just like setting up the frame, and then this parameter we have root because root is storing our tk. And then finally we have calc.grid. This is just basically making like a grid. So yeah, I'll let you guys copy like these first 11 lines or so, and let me know when you're done. Oh, can you guys hear me right now? Can you guys hear this? Okay. And then the second line is we're importing mass, and this is because since we're calculating stuff, um, we need things like square root and trig functions and pi. So those aren't available in like the regular Python. So you need to import the mass module first in order to use like these mass operations. And then finally we have the tinctor.message box in this third line. Basically, that is to create a pop-up such that when we want to exit the calculator, like this pop-up appears asking us if we want to exit, and then in which case, yes. So in order to have that pop-up appear, we need the .message box imported. So that's like the first part, which is just like imports and like stuff like that. So the second part is we're basically setting up like the structure of our calculator. So this first part is basically we're making the variable root stored like the TK class with like all the functions and stuff for setting up our calculator. And then we also have this root.title, and basically that is setting the title of our application. So basically it's like this top left corner here, you can see it says scientific calculator. That is what that is for. And then for this part, we are setting our background color as white. If you want to do a different color, you just type in a different color like red or blue, and then it will change the background color. However, it's not really noticeable on the calculator as the buttons take up a lot of space. So honestly, it doesn't really matter what color you put in, just put in a color. So in this case, I will put in white. This part, we are basically fixing the width and the height of the calculator. So it cannot be expanded and stretched. This is so that because especially when you shrink the calculator, a lot of the functionality disappears, and we don't want that. So it's easier to just have the calculator be non-resizable, which is why we set width equal to false and height equal to false. So this is like locking the calculator dimensions. And then this is setting the dimensions of the calculator. So here we have 480 by 568. That's like how big our calculator is. And then these plus 450 and plus 90 parts, those are just to orient the calculator. So like where it's positioned on your screen. So finally, we have this calc equals frame root and calc.grid.
Wait, hold on. They're not in the call right now. Sorry.
Oh, they're not on the call?
Yeah, I don't know what happened. Okay, I think they're back.
Okay, I'll just start over from like a couple of lines before. Okay, so basically, so this line 7, this is basically saying our background color, and you can put whatever color you want. Here I'm putting white, but ultimately it's not going to really matter because you can't really see the background of the color or the background of the calculator because the buttons all cover it up. So it doesn't really matter what color you put in here, just put in any color. And then we have this root.resizable. This is basically to make it so that the calculator size is fixed, because if we shrink or expand the calculator, then some of the functionality might be changed or hidden, and we don't really want that. So it's just easier to just make it non-resizable. So that's what this line is for. And then for line 9, we have the root geometry. And basically, this is setting the dimensions and the size of our calculator. So here we have it as 480 by 568. And then this plus 450 plus 90 is is like where the calculator appears on your screen, basically. So that's like saying that part. And then for calc equals frame root and calc.grid, that's basically making it so that way the buttons are in like a grid-like pattern, as you would see on a normal calculator. So that's what the grid is for. So if everyone heard that, then in that case, I'll let you guys like copy down like the first 11 lines of code, and let me know when you guys are done so we can move on.
Can you continue?
Oh, okay.
I think there is a problem, Discord problem.
Oh, there's a Discord problem. Oh, okay. RTC problem with cycling. Okay.
or you may copy the code and then they can just paste and then run the code if possible.
So can I move on, or do you guys need more time? Or what was that?
Okay, we need more time here. But you may copy the code, then they can paste it. You can share the code.
Oh, okay. So like, copy paste it into the Discord.
Yeah.
Okay. Okay, so I'll give like a couple more minutes to like let them copy paste the code.
Okay, okay. We are done. We can continue.
Okay. All right. So now that we're done with these two parts, we're going to move on to making the calculator class now. And basically, this is where we are going to be making the calculator's functionality and stuff. Oh, but yeah, by the way, this part is going to be kind of long. Yeah, so just bear with me. And we're going to just go through it step by step. So first, as always, we have like the class header. In this case, we've decided to call it calc. And basically that's what this first line is. We're just initializing the class as calc. And then for this next part, we have this this function, which is initialize, and then we have this parameter called self. You're going to see self in a lot of methods here. In fact, like almost all of them. And what self is basically it's an object that is defined by this calc class. So as the name kind of suggests, it's like taking itself as a parameter. So here we are initializing the class calc because we need it for our calculator, and we are essentially just initializing it itself, basically. So here we have some variables inside self. We have self.total, which is equal to 0. And what self.total is basically, this is like our answer, sort of. So like every time you input something into a calculator, you get like some kind of result that is stored in total. Current is somewhat similar to total, but it's a little different. Current is like what's currently being displayed on your calculator. So that's why we are making this a string as opposed to a number, because it could be it doesn't have to be a number necessarily. It's just whatever's being displayed on the bar where you're typing in your numbers. So that's current. Input value is set to true. This is basically testing whether we have inputted a value or not. Or I'm sorry, like whether we can input a value or not. So by default, it's true because we can input a value. Then we have self.checksum. And basically what this is actually, this might be better to explain later, but for now we're going to put it as false. And we also have self.op, This is basically our operations. So things like adding, subtracting, multiplication, division, those will be stored under the op variable. And then finally, we have result. That just basically tests whether a result has been made or not. So when you first open your calculator, obviously there's not a result yet because you haven't put in anything. So results will be false. And I will just like let you guys copy down like this first section over here, or I could just copy paste it into the Discord. Um. Okay. Um. By the way, when you're making the program, uh, and making the initialized method on the Discord message, because of like Discord's shortcuts and stuff, these double underscore characters do not appear. So make sure you add those. Yeah, because that's going to affect the rest of the program. So just like make sure those are in the method title.
Can you continue?
Okay. Right. So now that we have initialized all of the variables in self, we're going to look at the first method here, which is the first function here, which is number enter. And basically, we're going to be calling in two things. The first is self, because that's what we usually call for most of our methods here. And the second one is num, and basically that is the number that the user enters into the calculator. Okay, so the first thing that we're going to do is we're going to set result equal to false. So this might not seem obvious at first because we haven't talked about the other methods yet, but basically why we want to set the result equal to false is because usually after you like made a calculation, so like let's say you do like 2 times 6 and then you get 12, when you want to make another calculation, usually that's not dependent on the first one unless you do like answer or something. So in order to do that, we have to set result equal to false. We're basically making a new calculation. So this first num is, it says txt display.get. So basically what txt display is if we maybe it's toward the bottom, but like basically txt display is like the text box display on the calculator, and we want to get whatever numbers inside of there. That is because that is our first number, right? And then our second number is the one that we just put in, except we want to convert it to a string. And then here we have these two if and else statements. The first if statement is if input value is true. So if input value is true, then we would set the current one equal to second num, and then we set input value to false. This is because after we input something, we don't want to loop through it again. So that's basically what happens if it's true. And then if it's false already, then we have to check whether it's a period or not. And then basically, if there's a period, then we break. Now, this part might seem like kind of confusing, and with that, I'm gonna explain why we need this part. So let's assume that we don't have this part for now. Actually, let's just so we only have these lines, right? So let's go to our calculator. The issue is that you can press this period button multiple times. Here it's not displaying anything, but give me 1 second, actually. Okay, maybe that will work. Oh, okay, okay, like that, yeah. Okay, so basically, if you don't have that else statement, you can press the period button multiple times, and then basically it will register into the scientific calculator. And we don't want that because you technically can't have multiple periods in a scientific calculator, or any number for that matter. So to avoid the presence of multiple periods, we have to use that else statement. So basically, it's checking if we already have a period in our current number, then we should not add more periods to it. And for some reason, something's wrong. Hold on. Okay, there we go. So yeah, and then finally, we just display whatever is currently, like our new number. So basically, we are just displaying the new number that the user inputted. Or in the case of the period, we just return the same value because we don't want multiple periods. So if there aren't any questions, I'll just copy paste this, and let me know when you guys are finished copying it down.
May I continue?
Oh, sorry, was that so can I continue? Sorry, I couldn't really catch that. Okay. Guess I'll continue then. Let me know if you need more time though. Okay. So moving on. From this, now we have sum of total, and here in this function, the only parameter is going to be self. So here we have self dot result equals true, and basically what we're doing here is basically we're kind of programming the equal button. So what happens when we finally decide to get result? So because of that, we need to set result equal to true. Previously, it was made false, but now it needs to be set to true because we are making a result. Here, this is basically we are convert because if you look previously, current was initially a string. So we need to convert that string into a float so we can perform calculations on it. So this is basically that. We are converting the current variable from a string to a float. And then from here we check if the checksum is equal to true. And then if that's the case, we go to a different function. So what checksum is basically we are checking whether an operation has been made. So when you run the calculator, you can hit the equal sign without touching any of the operators, right? So if I just do 6 and then hit the equal sign, I just get 6 back, right? But if I do 6 plus 6, then I get, oh, what happened here? 6 plus 6. Yeah, then I get 12. So because of that, that's why we have this if and else statement. If is checking has an operator been done before we hit equals to? So such as 6 plus 6. So in that case, we will move on to this valid function, which I'll explain later. But if an operation has not been made and we just basically put in a number and then hit equals, then we just return that number back. So basically nothing changes. So I'll copy paste this code, or actually never mind. I'll explain the next one too because it kind of ties in with this function. So next we have display, and once again we have self as a parameter, but we also have value. Basically, what this does is that after you clear or you put in a new number, you want to get rid of the previous number that was in there because you want to make a new calculation. So this method is basically doing that. We are deleting the previous number, and then we are inserting a new number defined by value. So yeah, these are the next two methods. I'll just copy paste these in general, and you guys can copy paste the code.
Can you copy and paste the code to the general chat and share them?
Yes, it should have already been pasted. It's just the latest message.
Okay, you may continue.
All right. So now we have this valid function, and once again we're using parameter self because again we want to modify the class itself. So valid function was mentioned in the sum of total, right? Because we wanted to uh, call it once we found out that we were using an operation before the equal sign was used. So basically, here are the operations. So we have addition, subtraction, multiplication, division, and then modulus, which is remainder. And basically, like for example, for adding, if the operation was addition, then we add the current one to our total. And if you remember from earlier, total was our answer variable, sort of. So basically, we're adding current to the total. If we're subtracting, we subtract current from the total. Multiplication, we multiply them together. Division, we divide them, and then so on and so forth. So then we check input value equal to true because obviously once you use an operation, another number needs to come after it, right? So you can't have 6 plus and then that's it. Like there needs to be a number that comes after the plus. So that's why we set input value back to true. However, we do checksum equal to false because we cannot have another operation follow another operation back to back. So like we cannot have 6 plus and then divide. Like that doesn't make sense. There needs to be like a number in between the plus and the divide. So that's why we set checksum equal to false. So that way that does not happen. And then finally, we just display whatever the total is. So for example, if I run my calculator, and then if I do 6 plus 9, then without hitting the equal sign, it still displays the 9. So that's basically what this part is doing. I'll let you guys copy. I'll just place it in the general chat. And let me know if you are ready to continue or need more time. Sorry. Oh, you guys were ready? Okay. Alright. So, moving on, we have the operation function. And, here we have, self as a parameter. And then, we have op. Op is basically the operation. So, yeah. Um, so once again, we are converting the current value, which is like the displayed value, which is normally a string, into a float. So that way we can do math on it. And basically, if self.checksum, that's the same thing as this function over here. Self.checksum equals true, and just writing self.checksum, that means the same thing. So basically, if there's if we're allowed to have an operator, and we get one, then basically we will call the valid function method, and then do the necessary operations. And then else if, basically, if we are not allowed to have an operation, and the result has not been made, then basically we set the total equal to the current value, and then we set input value equals true, which basically means that we are allowed to input another value. So this might sound a little confusing, but basically what we are doing is, so when is self.result false? Well, it's false when you initially start the calculator, and it's also false. It should also be false after you equal, or somewhere here. Anyways, so basically we are setting, basically if it's false, then that means that we can put a new number in, and that new number overrides the previous number. So when we initially run our calculator, we can see that it's initially set to 0, right? But then what if I want to type a number like 98? That 98 overrides the 0 that was previously in the current variable, and that's basically what we're doing here. And then from here, we set checksum equals to true, which basically means that we are allowed to have an operator following that number, because we have a number in between, so it's fine. Then we update the operator, the current operator, which is self.op, so this is like the old one, with whatever the new operator is. And then finally, we set self.result equals to false, because since we have made new operations, the result is not going to be the same anymore, which means that we have to make a new result. So that's why result is set to false. And this is like pretty much it in terms of like the calculator basics, because the next methods are like, we are going to be programming each of the individual buttons. So here you can see some of these, but yeah, this is going to be the last one for as for actual like programs behind the calculator. So I would just like copy paste this in general. After this is done, it should be going a bit more smoothly, because the next couple of methods, even though there are a lot of them, most of them are becoming more and more self-explanatory. So this is like or I wouldn't say the last hard part left, but like it's a big hurdle that we have gone over. So yeah, just let me know when you're ready. Okay, so it appears that we are ready, I think. So I'll be moving on to the next function. Here we have clear entry. If you look at the calculator, this is the CE button. And basically, we are just clearing the current entry. We are not clearing all entries in the past. So this is just like, I mean, it's basically how a regular calculator works. So basically, self.result equals false because we're not making any results because we're clearing it. And then we're going to set the current one equal the current display equal to 0 because we are clearing it. And then we're going to display that 0 because again we're also clearing it. And then we set input value equal to true because now that everything has been cleared, we can start accepting new inputs from the user. And that's why we set equal to true. Now for all clear entry, which is basically the C button, that deletes everything. So basically we'll use the clear entry method in self, and which basically it'll call this method up here. So it'll basically do all of these things, but then it'll also set total equal to 0. So that way everything is cleared. So yeah, those methods are kind of similar. And then from here, we're just going into the main methods with the mask buttons and stuff. So we're going to do pi. So here we have pi self, and then self result equals false. Again, that's also because when we input a number, in this case pi, we're not getting a result, so result is set to false. And then self.current, we have mask.pi. This mask came from the import mask that we had at the beginning of the program. And from that mask module, we are calling the pi. So that way, it's basically Python's built-in version of pi. So we're going to set that equal to the current variable, and then we will display the current variable. So it'll display 3.1415, whatever the next digits of pi are. And tall is basically 2 pi, so we basically do the same thing. Except we replace pi with tall. You can also do mass.pi times 2, because that's basically what tau is. So either mass.pi times 2 or just writing mass.tau is acceptable. Personally, I would prefer doing mass.tau because that's just the name of the function and it's better to just be consistent. So I'm gonna copy paste these 4 entries into the general chat, and then it's probably also a good time to like stop because I'm not sure if we might have enough time to go into the next operations. So yeah, just once you're done, just let me know.
So I think this will be the end of today's class. You say something?
Oh, no, I didn't say anything.
So for today's homework, it's to review today's lecture, which was about machine learning and the calculator. And for those who didn't get their Python intermediate certificate, try to get that done as well. Again, thank you for coming, and we'll see you tomorrow.